Alright, so this is where we compare the position of a point to another point. So for example, in that video, relative to Vin Diesel, what's his name in the movie? Riley, what's his name? Dominic. So relative to the bald guy, the other guy is really not going anywhere because they're going the same speed at the start anyway. Right? So just think about that sort of concept. So not to the origin. Now obviously if you were a cheerleader or a bystander and you were at the starting line, you would see all four cars take off really quick. But if you're in one of them, you'll be moving with them. So really, to you, they're not going anywhere. Einstein figured that one out. Okay. So you want to ask the question, what is my position relative to another? Was it Dominic? Yes. It was Dominic, wasn't it? What's the other guy? Paul Walker? Brian Walker? No. Anyway, moving on. So, think about this point A and this point B. What is position B relative to A? So, in other words, if I was at point A, how do I get to point B? Right? So, we basically want A, B. If I was at point A, how do I get to point A, B? Now, how would I figure out the vector A, B from my position? So from my origin, which is O. Yeah. Well, I would say, well, I have to go negative OA plus OB. Alright, negative OA, so I'm going to go this way, down to here, and then I'm going to go OB. So I substitute it in, I substitute my vectors in. Now I'm going to use it in matrix form, just because it makes it a little bit easier. So that's 5i plus 2j minus 4, 10. So let's see, let's just check that. So, 1, 2, 3, 4, 1, 2, 3, 4. Yep. Okay. And then I just simplify that. 1, negative 8. Now look at that diagram. Is that vector correct? If I was at A and I go positive 1i and negative 8j, do I end up at B? Yes, I do. Look, positive 1i, negative 8j at B. Now, if you were at B, if you were behind, like who was the last? Tyrese Gibson. That was the black guy. If you didn't know, he came in last. If you were last and you wanted to get to A, what would your position be? Alright, so the same sort of thing. We want to go BA. So from B to A, we go negative OB plus OA. So negative OB, where's OB? 5, 2 plus 4, 10. Alright. And then I get 1, negative 8. Do you see the relationship? From going from A to B and B to A, it's quite obvious once you see the numbers. Sorry. Thank you for picking that up. Yes. So the relationship is that the signs are just swapped. Just some terminology, so some symbols and whatnot. If we want the position of B relative to A, so just like example 1a, here's how we write it. So the position of B relative to A. Sorry, R is the vector. A and B are positions. Okay, so R is the vector. We're going to do a little vector sign on the vector. Okay? And then obviously the position of A relative to B is A relative to B. Now think about how we got these vectors up here. Alright? That's A relative to B, and how we got that was negative OB plus OA. So the general rule for B relative to A would be the vector of B minus the vector of A.
Is that the position vector?
Yes, so these are position vectors. Thank you, Matthew. So now look at this and think about it algebraically. How would I get the position vector of B, for example? Any volunteers? How would I? Yep, I would move this equation around. So the position vector of B would be B relative A plus relative A. Okay, so I got two rules there. That one and that one. Now I'm going to take those rules and put it into practice. Just like that video. Except not that video, because that's illegal. Don't do that. Alright, a ship A has position vector of 20i plus 10j. Relative to an observer on A, a second ship, B, has a position vector of 3i minus 8j. Find the position vector of the second ship. So, relative to the observer on A, B from him or her was 3i minus 8j. So let's draw a little diagram here. Let's do little axes. Let's do some axes. Okay. So we know the ship A has position vector 20i plus 10j. So it would be roughly 20i. Let's just say it's there. Okay. Here's a quick sketch. So that's 20i plus 10j. That's A. So relative to that, we have B. So we're going to go 3i minus 8j. This over here is B. Now you can already see visually what the position vector of V is. It's just right 3 units and then down 8 units of A. Mathematically, that's exactly what it is. So we're just going to put it in the notation. So so the position vector of A is 2010. The position vector of B relative to A is 3, negative 8. And we want to basically find the position vector of B. So lo and behold, as you can tell, we used this formula there. Pop it in. Now, does everybody see why we use that formula? Because we have to move from there to there, so we need to just add it on. Plus 3, negative 8. So that's 23, 2. So B is 23, 2. Any questions, people? Questions? Queries? Everybody understand relativeness? Alright.